Okay, so I'm Panagiotis Bountzioukas, or Panos. I'm representing the agency. I'm a CubeSat testing engineer and a systems engineer working in ESA, Galaxia in Belgium. Someone could say, why just CubeSats, since we are supporting also PocketQubes for more than 1.5 years. So PocketQubes and CubeSat systems engineer and testing engineer. So a little bit about the agency. So we have multiple sites all over Europe. And there is one small there, which is for the French Guiana spaceport. And this is probably could possibly be from where the PocketQubes we support will get launched from. But we'll see, hopefully. Now, what we do as an agency, we have 23 member states. It used to be 22 up until the January, but then there's also Slovenia, so we are now 23. Why Europe is into space? Now, just one thing before I continue. For those that don't know, ESA is European Space Agency, but it's not European Union Space Agency, and there's a there is a difference. And the difference is that there are the associated states, and there's Canada, and we are two separate agencies. We sometimes and lots of times cooperate with each other, but we're not the same. Okay. So we've launched no. Okay. Yeah. So we launched 100 satellites since 1979. Stay. Yep. And we had multiple launches from Kourou. Commercial ones are included here as well. Now, one of the pillars of the agency is education. So what we do as an agency, we try to give back to the member states. Every year we have the ministerial. That meaning we have a specific budget being gathered. In the previous slide there was 7.7 billion, which equals to 15 euros per person per European citizen, more or less. And every year we get a different contribution from each state. Now, this money are also being given for the agency to give back in terms of sharing the know-how, preparing the new generation for the next generation for the for them becoming engineers and becoming members of the European workforce. So this is a big pillar for us, and what we do is we have the education program which spans from elementary, from first level of education up until tertiary. So we help through. I'll find it. So we help with having give me a second. So we help with this. So we have training programs so that we start from 1 week up until 4 weeks. And then we have the project program for which I will talk about during my presentation. Then the engagement program, which is with which we support students like the ones attend here through sponsoring them for attending conferences and workshops and everything. So this is an overview of what is it that we do. So for this one, this is basically I will focus more on the training sessions, but most of all for the Fly satellite. Now again, the three different sections of ESA education. So we have the training, where we have the training sessions. These are being realized mostly in Belgium, where in my site. And we also have the online training, which is something that's been realized as we speak. And we will try to have, we will try to shift towards an online platform for everything that, from everything that it is that we offer, so that we expand the offer of education in for more people. And doing so, we will also try to incorporate new disciplines when it comes to space engineering and education, but not only space engineering. We are talking also about life support. We are talking about space law. We are talking about project management. So these are things that are being implemented as we speak, and we just started to pilot some sessions, and we will see how this goes, but it's within our plans to do so. Now, for the projects, this is basically my field. So I'm in satellites, but we also have the experiments, and we offer parabolic flights testing, the robotics laboratory. Space Rider has already been closed for the experiments for that one, but we do have academia teams and universities that will have payloads in Space Rider maiden flight. And then again, we have the ISS experiments, which is basically Ice Cubes initiative. Now, and of course, now it's Fly Your Satellite. It's what I work with. It's basically what we do. Engagement is just, sponsoring students, but also if there are people here that is doing a master, finishing masters, or a PhD or postdoc, whatever, we have multiple opportunities, which you can see later on. I have a QR for you. Okay, let me go a bit on the training. I will later on continue with Fly Your Satellite. Again, this is 1 to 4 weeks. We have, this is our training and learning facility in Belgium. And this is an overview of what we do. Most of this, we do all of these things. You can see there, it's our lab. I have a separate slide for this. There it's either RF testing or EMC testing, just mentioning that it is possible for you to test using ESA facilities, even in ESTEC, but it has to be within these programs. There is such an opportunity, though. Fly Your Satellite. Okay, so Fly Your Satellite started, I think it's now 6 years ago, maybe, until it gets properly, it could be considered as a proper program, not just a pilot program. So what is it that we do, me and my colleagues? We basically get a call out, and then we set specific guidelines for it. We give the students, that are being selected after a selection process, they have to follow specific guidelines, and we have a separate tailored standard for them that follows the CubeSat design specification and the PocketQube design specification when it comes to PocketQubes, of course. So then we get a data package, we review, and we select. What happens during the program? It depends on what we said that we will do when we kick off it. And what is it? Might be phase B, might be phase C, might be phase D, which is now the case for Fly Your Satellite 4. And we help them along the process. And we, of course, love the documentation, unfortunately. So this is something we give a lot of focus on. And throughout the process, we have specific milestones and deliverables, which follow exactly the timeline that a typical space program within ESA would follow. So we do, after the end of phase D, basically, we start with environmental testing. For CubeSats, the case is that we do subsystem level testing. For PocketQubes, this is something to be discussed. Of course, people follow the approach of proto-flight model testing, which makes sense. So that there is a distinct difference. But what is it that you need to keep from this is that we offer environmental testing facilities. And we go hand in hand with the students to show them how to do it and qualify and accept their item under test, their satellite, their subsystem, anything. And of course, then we cover the launch opportunity. Okay? So we pay for it. But the students, the teams, have to pay for the development themselves. This is the portfolio of our Flyer satellites. So on top, you see the ones that are being launched already, that frame. And then you got the design support, which is for satellites that take part in Design Booster. I have the next slide. And the in-development ones are the ones that participate in Flyer satellite program, the current one. The current and the previous edition, more on the next slide. And the testing support ones are the ones that we have an opportunity, a testing opportunity for everyone, basically, as long as it's academia, of course. And the opportunity is that we open some specific test windows within the year, and you can apply for it and get selected, and within the span of 5 months, test your device. Okay, so to speak about PocketQubes in particular, for the new edition of Flyer Satellite, we have those two teams. We support them already from phase D. I'm not going to say anything about them, because then I would, what are the students going to talk about? Because they are here, so they will say things themselves about it. Now, these are the opportunities, and this is what anything that entails Flyer Satellite. Now, you see that we had the second edition. First was the pilot one. The third one, there are currently 2 teams closing MRR as we speak, and they continue with system level testing to be able to qualify and after the acceptance test, fly the satellite. Now we are in the 4th edition. So for the first time, we have the PocketQubes, 2 PocketQubes. And there is a faint number 5 there. This is for a reason. And the reason is that we are into talks kickoff with Flyer Satellite 5. I'm not sure when. So maybe even within this year, but nothing is set in stone. So. And then the second big program for your Flyer Satellite project is the Design Booster. Now we are in the 2nd edition. We kicked off on January, so as we speak, we do the data packets review for them. It's the baseline design review. Now for the testing opportunities, the things I mentioned before is that we just closed the window previous week for a test on July, but we are planning on reopen it, and basically maybe you prepare your phones, because I'm going to share a QR with you in case you want to participate. You can ask for any documentation you might need about the facility, and it's basically part of the, you send an email and that's it, basically. The training session, of course, we have a lot of them. We have specific one for Flyer Satellite program, the ones we support. So we have the CubeSat Concurrent Engineering Workshop. This one is CubeSats, I'm afraid, because they use a specific device, education device, and it's not PocketQubes, but maybe we expand. And I think this, you see it here, basically. We have these things here. So yeah, maybe we expand. It's something we are discussing about. And then we have the summer school every other year. It was in 2024, and now it will be in 2026. The CubeSat hands-on training and the spacecraft testing workshop. The last one, I'm afraid that the deadline closed also this Sunday, so it's not possible. This is being realized from us inside the testing facility. And for sure, next year we're going to introduce an exercise with PocketQubes. So a bit more on the testing opportunities. So what is it that we do? We select a team. You apply, we select you. We prepare together with you the documentation, the testing specification, and the test procedures. This program again lasts for 5 months. Then you do the test with us. We have meetings every 2 weeks almost. And then we have the test itself, and then the teams should deliver a test report and a presentation for all the rest of the teams that participated in the past as well. So we are currently supporting 2 teams. One of them is testing a drug sale as we speak. And this is the QR for the testing opportunities. In case you want to use it, but you can find it later, or you can ask me. You can find me here, please feel free. Now, my facility. So it's an ISO 8, but we can go to ISO 7, and this is what we normally use during tests. We use it for testing all sorts of experiments. Not just CubeSats, not just PocketQubes, but we also use it for Exus-Bexus experiments, which basically is a payload for rockets, and for ISS experiments. But it should be in nice cubes form, meaning that in a CubeSat form. But we are open to anything. It's just a testing opportunity. As long as there is academia, it's okay. So we have a shaker, a thermal vacuum chamber. We have electronics equipment, RF testing equipment, Genesis repeaters. There you can see the data acquisition system that we need for us to speak with the TVAC chamber. And we constantly expand the things we offer, and we are buying new equipment all the time. So now, it's also should be named PocketQubes support facility, since when we started it was CubeSats, but now I think we try to find a new name. But yeah, so here you can see a hanging setup for the environmental testing of PocketQube. It's nothing. It's a simple design by us. So it's modular so that we can have we can change between the forms, and yeah, I mean, it is what it is, and it works. So, and we also have procured a testing adapter, both clamping and with a spring. So, and also mass dummies. So we are basically, as of now, we are open to testing PocketQubes. This is a stray slide. This is actually where the teams we have for FlyU Satellite 4, the current edition, and this is their face. Yeah, sorry, I should have been before. Now, why PocketQubes? Let's delve a bit more into the PocketQube world. Someone would suggest that it would be a faster development. And what we hope, because we also learn ourselves about PocketQubes, is that we won't compromise quality or quality of work or or sacrifice, I don't know, processes or anything that might compromise the end product, the satellite itself. So it's fast. It should be faster development, but we don't know actually. This is something we learn ourselves. We hope. Why do we hope? Because we want. What we see through the lessons learned from the previous editions is that student teams have a huge problem with human resources. Students come and go, and then there is a serious issue with knowledge transfer. So we want to tackle this a bit. This was part of one of the reasons why we decided to go with PocketQubes ourselves. We'll see. We also have a serious issue with CubeSats. So this is more why not CubeSats and why PocketQubes, this argument. So someone would say that it takes a while to procure all things and then maybe legal issues, NDAs with long lead time items. So hopefully with PocketQubes something we tackle. One of the reasons, again, it's cheap. Of course, it's way cheaper than a CubeSat. And this is, of course, something, since we do not sponsor the development, this is something for future PocketQube teams to consider, that they could actually fly using a cheaper bus and do the same thing, more or less. They want the same thing they intended with the CubeSat. And still, this serves as a great demo for us to have all the processes we already use for CubeSats. So this is something we showcased during last year. So we have a specific tailored version of the initial PocketQube standard, which we use for Fly Your Satellite. Again, because I feel like there will be questions on this, this is only used for Fly Your Satellite. These are not ESA standards. Okay, these are program-specific standards. So we had version 1.1. We tried to incorporate everything that there was already. This we did, everything that was already in the initial PocketQube standard. And then we added some touches, some explanations, we changed a bit the order, maybe we refined a bit the phrasing. And this is also something we did with version 2 that we are currently reviewing. We just did it actually last week. So what we do is that we already saw the issues that might come up during development of our PocketQube teams. And so that and there were some questions, of course, so getting their feedback, we used everything to create version 2. And yeah, I mean, there was a lot of work being done with this, and it already looks great, but again, this is my take. Okay. I wanted to say something about this in particular. Yeah. Don't have my notes. I'll skip it. Now, the challenges, of course, apart from the ones I already mentioned, you see multiple points here, but the ones that really bug us, and we have we have to think a lot about them, is the launcher availability. So we do know that it's a very limited, the launching providers are very limited launch brokers. So this is something we like, honestly, we like to have multiple actors, and so that there is a bit of, like a bigger market. So there are options, and But I mean, there are launchers, and we are here. So again, but still, this is an issue. The main issue for us is the lack of codes. So if you are a PocketQube developer, most likely you will, not most likely, definitely you will use in-house systems. So that's a huge difference from CubeSats, and this is what compromises a future mission, because an in-house is an in-house. There is no legacy, there is no heritage, so this is indeed an issue. From system engineering point of view, we do exactly the same, but we see the main issue codes is that the one I already mentioned, that the model approach is PFM usually for PocketQubes, and we don't do it. That's not the case with CubeSats, and this is something we discuss internally on how to approach it, because we would be interested in doing subsystem level tests. But again, we will see. And the main issue, still many of you probably share this concern or you have this issue, is the space debris mitigation issue. So we have a specific one. We have the ESA SDM policy we need to comply with, at least we, in ESA. So we have an issue with 1P. And of course, the issue is how to improve trackability. So this is something we are in talks with. We use simulations. We already have the experts that review the data packages from the PocketQube teams raised questions, and I mean, both teams have issues with this, and this is something we are following closely. For sure, there will be some sort of wavering when it comes to 1P, but in the future, we should, as actors in the industry, to find a way to improve trackability. That meaning, I don't know, reflectors or hardware, specific hardware that we need to have on board to improve this. This policy is ESA space debris mitigation policy. This applies to all the states and each and everyone that signed them, basically. Now, I'm finishing with this slide, basically. We have ourselves, we have an issue. We are new to this world, to PocketQube world, so we ourselves learn through the process, and we are not experts, and this is something I want to make clear. We are experts when it comes to anything else, but we are new to this one, and we are open to any discussion with you, with the industry and academia, and hopefully what we want to do is standardize a bit the processes that we follow, change, tailor them around PocketQubes, and hopefully for the standards that we are preparing, we might try to use to incorporate things like requirements, design as you test requirements. That meaning that I will bring an example. I actually have the example there. So we see for testing, for instance, you want to do system level testing and you use the thermocouples, but later you have to cut them and passivate them. So we have to have in mind that there should be a hole someplace to passivate them, like a terminal for us to solder them or something. And this could suggest that we would require some design changes on the buses on a requirement level. So these are things we learn, and we want to incorporate. So voila. Okay, thank you. Oh. Questions?
Thank you, panelists.
Thanks.
Do we have any questions for panelists? We've got time for maybe one or two. No questions for panelists, so here.
Thank you for your presentation.
Thanks.
Listening to the Fly Your Satellite initiative, I think it's really very noble. But I was just wondering how you would address the concern that some people might have that sustainability, that space sustainability doesn't appear to be as high on your agenda as it needs to be, in the sense of the PocketQubes and the CubeSats that we are putting into orbit. Is it for any very specific, unique mission, or is it just to satisfy the hobby of enthusiasts to have something in orbit that they can play with the data?
Okay, thanks for the question. No, space sustainability sometimes sounds a bit. It's like towards classing, because you are what is it that we do, all of us, is that we are getting some space debris into space. But for me to, this is not just for education, okay? Yes, it's education. Our Fly Your Satellite program entails education. It's an educational program. But there are missions. The missions there are destined for. We have a mission that has to do with GPS data mapping around Earth in LEO, and this data will be used later on for enriching the existing database, so that every payload there has a scientific goal. So it's not just for us to get something up there. It's for us to and play with the data. I wouldn't use the word play. For each and every one of these missions, since they were being selected carefully, there is a specific and significant value. And it's not the one. The main goal was education, but there is always the added value, which is the payload-specific one. And there is always value in what is it that we chose in the beginning. So we don't expect, a team for Fly Your Satellite 5 that I mentioned, we don't expect a team to come and say, we want to get something up there for, to take some pictures and that's it, and this is the demo, okay? So we expect something more. We explain the value. So in that term, just to address the sustainability thing you mentioned, it's already the value itself that tackles sustainability. Sustainability. For us, when we say sustainability in space, for us, that means that we have a way to maybe incorporate many things into a bus, for instance, and then go back. This is the space rider. So we have multiple payloads on space rider, and then it goes up and then it goes down. This is sustainable, right? Because you have reusability of the bus. So unless I miss something on your question. We have different projects that are sustainable, like the ISS experiments or the Space Rider, but for Fly Your Satellite, it's business as usual. You get the satellite up, and then you are obliged to conform with the space debris mitigation policy, which suggests you go back, you make the entry within 5 years. So sustainability, yeah. So we have reusable platforms, and then we have CubeSats, and we cannot do anything else about CubeSats, you know. Hope that covers you. Okay, thanks.
Thanks. Do you have any more questions for Panos? Over here.
Could you tell us a bit about the eligibility criteria? Like,
About?
in the,
Sorry.
for example, on a private satellite, sorry.
Yeah.
For example, like a startup can apply or
No.
university.
Okay. It's destined for university teams. University. You can always apply. You know.
And how many people will reject it?
You don't want to get rejected. I get it. Okay.
How many people are applying and how many are awarded?
How many people apply
Applying to this success rate?
for Fly Your Satellite program?
Yeah.
How many teams? Okay, not yeah, that's what you mean. Yeah. For the last edition, it was maybe even 10, and 4 were selected. Maybe 8. I don't remember. Yeah, but yeah, for sure, this is given that you have to have academia within the team, people from academia. But yeah, if you are a university startup or something, this yeah, you can always ask. Where is it? Oh, where is it? CubeSats@esa.int. You can send always an email to us and ask.
Okay.
We will be happy to help.
And then about the commitment and in-person commitment, like,
Commitment.
yeah, like you had to fly somewhere, like I didn't understand where is where are you going to do the test campaign, for example?
Okay. So you want to know how much you need to commit? Sorry. Yes?
Sorry?
About the commitment, you say.
Like, do you have to travel somewhere?
Oh, yes. Yes. Yeah, I didn't say it. You're right. Yeah, you need, for the testing opportunities, for instance, which you could probably apply as long as you have academia. You can, yeah, we cover expenses. Basically, you travel over to Belgium, to this amazing village. And yeah, you share a hotel with some cows, and you basically test then for a week. And yeah, that's it. We pay everything.
Like, how can someone apply for online trainings?
Trainings.
Yes,
Okay.
online courses.
I think it's this one.
Okay.
Yeah, I think it's this one. Yeah, this is his academy. This is for trainings as well. You can find it there. So, yeah. And yeah, you have to check regularly because we are getting some more every month or something.
I've actually got a question for you. So how can teams improve their applications? Because I was fortunate enough to come to your batch 4 intake. Obviously, you're saying you got 10 applications there. Like, obviously, you're looking for quality teams as well. So like, what can a team do to catch your eye, and like what sort of behaviours and application would you like to see from teams? Because I think that's a great thing you can get from this event is that there's lots of people trying to do it on their own. They're trying to get teams going. They're trying to do things. So what would you like to see from teams that are applying to Fly Your Satellite program?
Okay, thanks, Tom. So we have specific guidelines to begin with. We have the design specification that we share with those teams. So they need to prepare the data package in a specific structure, following a specific structure.
Can you tell like which teams are going to be successful based on the way you interact with them? Like, is there any correlation between like teams that are really like keen to submit stuff, or like is there any traits you found working with teams that like are positive?
Sorry,
So obviously you fly lots of satellites. Like in terms of like getting new teams in, like have you seen any traits or any qualities that differentiates between a team that's maybe going to be successful and a team that has issues?
Yeah. Well, we've seen a lot. And
Spectrum.
yeah. You see, most of the times the differences are very distinct, and the differences are huge. So you see, the maturity of the proposals are. Usually there is one that is definitely getting. We have a selection process when we have for instance, we have specific qualities that we use and specific weights we apply on each of them. So we have our checklist. Yes. So I'm not going to share the checklist exactly, but something general I can say about this is that we expect proposals to be to follow the guidelines, to be honest, yes, because we review a lot. So this is what ESA does, the review. ESA reviews. ESA doesn't fly any satellites. ESA reviews documentation. I'm lucky because I have a lab, but okay. So yeah, let's say we don't have something like an eye catcher. They need to use it, but definitely a good proposal is accepting the phase for which we are asking application for, and being within that phase.
Right. Yeah.
So because
Yeah, so don't oversell it too much, but obviously if you make progress, that helps,
Yeah.
Awesome.
But yeah, that's it.
Great. Well, big round of applause for Panos. Thanks for coming today.
Thanks.
Really appreciate
Thank
it.
you.